You ever just open Instagram and wonder how, in a split second, your feed is perfectly populated with everything from everyone you follow? I mean, it feels like magic, right? Well, it's not magic. It's actually a masterclass in system design. So today, we're going to pull back the curtain and really dissect the engineering that makes this everyday feature possible. Okay, so let's get right to it. This is the big question. We're not talking about a handful of friends here. We're talking about serving hundreds of millions, maybe even billions of people all at the same time. How on earth do you build a system that can handle that kind of pressure without just falling over? Well, let's break it down and find out. So, before we can even dream of building the newsfeed, we've got to lay the groundwork. Just like building a house, you need a solid foundation first. So let's start by breaking down the absolute essential features an app like Instagram needs to even function. And here they are. It's actually pretty logical when you think about it. First, obviously, you need a way to store and retrieve images. Then, you need to let people interact with those images. That's your likes and comments. Third, you've got to build the social graph, the connections, by letting users follow each other. And then finally, the whole reason we're here, putting it all together to publish that newsfeed. These are fundamental building blocks. All right, now we get to the really fun part. To build that feed, we first have to figure out how to represent all those relationships between people and their posts. This all comes down to how you structure your data. So let's see how we can store every single like and follow in a really efficient way. So here's our first little design puzzle. You can like a post, sure, but you can also like a comment on a post. So do you need two totally separate database tables for that? One for post likes, one for comment likes? Or is there a cleaner, more elegant way to do it? And here is that elegant solution. Instead of juggling multiple tables, you just use one. The real magic happens in these two fields right here, parent ID and type. The parent ID is just the unique ID of whatever got liked, and the type column tells the system what it was, a post or a comment. It's a beautifully simple design that's also incredibly flexible for the future. Now let's take that same simple is better approach to the follows table. This one's even more straightforward, believe it or not. With just these two key columns, follower user ID and followee user ID, we can instantly answer the two most important questions. Who follows this person, and who does this person follow? It's simple, powerful, and crazy fast to look up. Okay, so our data models are set up. We're ready to tackle the main event, generating that newsfeed. Now, the most obvious way to do this, the way you or I might sketch it out first, is what we'll call the brute force method. It makes a lot of sense, but it has a massive, and I mean massive, hidden flaw. So here's how it would work. Every single time you open the app, the server would first have to look up everyone you follow. Then it would go and fetch the recent posts for every single one of those people. And finally, it would dump them all into one big pile, sort them by time, and then send the newest ones back to your phone. Makes perfect sense, right? On the surface. Well, here's the fatal flaw. Imagine millions of people opening the app at the same time. The database would get absolutely hammered with requests. All this fetching, combining, and sorting over and over again for every single user every single time. While the logic is sound for a small app, at Instagram scale, it would just crash and burn. It simply cannot scale. So if building the feed on demand is way too slow, what's the alternative? Well, this is where the engineers had a brilliant aha moment. It's a huge architectural shift. Instead of waiting for you to ask for your feed, they decided to build it for you ahead of time. This is the absolute key concept, pre-computation. The big idea is to shift all that hard work from what we call read time, that's when you open the app, to write time, the exact moment someone you follow actually makes a new post. This is a complete game changer for how fast the app feels. Let's walk through how this new flow works. So when I post a photo, the system doesn't just store it away. It immediately looks up every single person who follows me, and then it goes and inserts my new post directly into each of their pre-built news feeds. The heavy lifting only happens once, right when the post is created. And where do these ready-to-go feeds live? Not on some slow, old database. No way. They're kept in a super high-speed in-memory cache. Think of it like a server's short-term memory, probably using a tool like Redis. This means when you open the app, it's not doing a bunch of complex calculations. It's just grabbing a file that's already sitting there waiting for you. And that is the secret to that instantaneous, magical feeling. So, we have our amazing pre-computation system. Everything's lightning fast. Problem solved, right? Well, not quite. There's one giant, glaring edge case that can bring this whole clever system to its knees. And that problem is celebrities. Just think about it for a second. When an account with, say, 10 million followers makes a post, our pre-computation logic would try to update 10 million individual news feeds all at the exact same moment. In system design, this is sometimes called a fan-out problem. And trust me, it's a recipe for a complete and total system meltdown.
So to solve this, Instagram uses two different strategies. For most of us regular users, it uses the push model we've been talking about, where new posts are automatically pushed into our feeds. But for celebrities, it switches to a pull model. That means your app has to actively ask or pull for that celebrity's latest posts when you open it.
So the final elegant solution is this really smart hybrid model. The system is clever enough to identify those accounts with tons of followers and just treat them differently. It blends that seamless push model for most of us with the server-saving pull model for the massive accounts. You really get the best of both worlds. So let's just quickly recap the big lessons here. We saw that you should always start with simple, flexible data tables. We learned that the obvious brute force solution almost never scales. We discovered that the real secret to a fast feed is pre-computation, and that it relies on a super fast cache. And finally, we saw how the most robust systems use clever hybrid models to handle those tricky edge cases, like the celebrity problem. What's so fascinating is that this design isn't unique to Instagram. As this quote points out, this fundamental architecture, this idea of pre-computation mixed with a hybrid push-pull model, is pretty much the backbone of almost every major social feed you use every day, from Facebook and Twitter all the way to Quora. Seriously, this pattern is a foundational piece of the modern internet. So the next time you're scrolling through an app, just stop and think for a second about what might be happening behind the scenes. Where else can you spot this elegant little dance of push and pull in the apps you use? It's a pretty cool design puzzle hidden right there in plain sight.